Alright, so you want to learn how to make a crappy platformer? Well, you're definitely in the right place. With that said, let's get started. Okay, before we start, what are we actually trying to make? Well, this is pretty much what we're trying to make here, so, our player can double jump, and if he touches the spikes, well, he dead, basically. So, yeah. Also, if he falls off the stage, he gets respawned. So look at that, we have a simple respawn system, I guess. And if you play throughout the stage and you make it to the exit, then, you're taken to the next stage. And if you're on the final stage, and then if you actually make it to the exit in the final stage, it takes you to the win screen. And look at that, it's beautiful, I know. And if you press the quit button, it quits the game. Look at that. Now to actually set player movement, we kind of need to, set a player. So add a kinematic body 2D, a sprite, a collision shape 2D, a animation player, and an area 2D as children of the kinematic. And yeah, that's our player. Now click and drag a sprite into the texture field of our sprite node, and then the collision shape 2D, set up a shape for it. I'm using a rectangle, and then just resize it however you want. And yeah. And now I'm moving it up. You don't have to do this. I'm just doing this just because, I guess. Anyway, add a script, and yeah.
Big brain time.
Big brain time. Anyway, in our script, set up a bunch of different variables for things such as acceleration, max speed, friction, and so forth. Now, I'm using export variables for this so that I can actually tweak the variables as I'm testing the game. So yeah, big brain. Anyway, set up a function process, physics process delta, and then do pass for now. And then we want to do function get input vector, and this is what we're going to use to get input from our player. So var input vector is equal to vector2.0 for now, and then input vector.x is equal to an input that we haven't set up yet. So project settings, input map, and then set up the actions that you want, such as move right, move left, jump, and then click the plus, and then assign whatever keys you want to it. And you can assign more than one key if you want. I'm just doing one because I don't know, I'm lazy, I guess. And then back in our script, do .get action strength move right minus input .get action strength move left. And then pretty much we're returning whatever that value is. So this is pretty much gonna return a vector that's gonna determine the direction our player is moving. Anyway, let's actually apply our horizontal movement now. So I add another function called apply horizontal movement. Now you can call it whatever you want. You just gotta make sure you actually pass input vector and delta to it. And then if input vector .x is not equal to 0, meaning that we're actually moving, we want to apply our motion to our motion vector that we actually just set up just there. So motion.x is equal to input vector.x times our acceleration times our delta value. So now we actually want to clamp or limit our max speed that we can reach. So motion.x is equal to clamp motion.x, and then comma minus max speed comma max speed. And then in our physics process, we want to set up another variable of input vector that's equal to the return value of the get input vector function we made. And then we want to call the apply horizontal movement function and pass input vector and delta to it. And yeah, hopefully your brain's not fried at this point. Anyway, I added a new scene, and I just added a static body 2D with a collision shape. And then I, gave it the shape and resized it, and then I duplicated the static body with Control D, and then in debug, make sure visible collision shapes is on, and then instance our player into the world scene that we just made. And yeah, if you play, yeah, it's not moving. So back in our script, we want to actually make sure we do move and slide motion. And look at that, he's actually moving. You can barely tell since it's so tiny. So yeah, go to project settings, and then under display window, in the width set it to be 320, and then the height 180, and then test width we want it to be 1280, and test height to 720. Now scroll down, and then the mode set it to 2D and aspect to keep. And make sure that this is actually plus equals, not equals. And now if we run it, look at that, our motion's working. So now you can celebrate like this mad lad here because it's working. Also, this is what happens if you don't actually limit or clamp your speed. So unless you want this to happen, then make sure that you actually have that line of code. Anyway, let's actually apply our friction to our player now. So function apply friction. Now, like I said, you can name these functions whatever you want, but do make sure that you do pass the input vector to it as well. And then if input vector dot x is equal to 0, meaning that we're not getting any input from the player, then apply our friction. So motion dot x is equal to lerp motion dot x, and then the value we're trying to head towards, so 0, and then friction. And then you can control click on lerp, and it basically tells you what that method does. And yeah, make sure you actually call it in our physics process delta function and pass input vector to it. And look at that, we actually now have friction in our game. Beautiful. Now let's actually apply gravity to our game, because having gravity is kind of important in a platformer. So to do that, we want to do motion.y is equal to gravity times delta, and it should actually be plus equals gravity, and then pass delta to it and call it in our physics process function. And now if we play, bam, we have gravity. Beautiful. Now there's a slight issue where gravity just keeps on increasing without end, so yeah, that's something we need to fix. So to fix that, we just need to add an if statement. So if not is on floor, then do the code. So just indent that. And then in our function physics process, we need to actually add this to our movement slide. So motion comma vector 2 dot up, and this is gonna define the direction of our floor basically. And it's kind of weird in programming. And now, as you see, our gravity actually stopped increasing. And that's actually now limit what the max gravity can be by doing motion.y is equal to min motion.y gravity. And this limits the gravity to the amount we specified up here. And now it's time to actually add our jump to our player. So function jump, if input is action just pressed, jump, and then motion.y is equal to minus jump force. And call this in your physics process, otherwise it won't work. And if we play, look at that, we have a jump, but there's a slight issue as well where we can kind of just keep on jumping forever if we want. So to fix this, just add this if statement, so if it's on floor, and then do the code. And now we're pretty much just adding an additional functionality where we can get a variable jump. So if input is action just released, jump, then motion.y is equal to minus jump force divided by 2. And actually we want it to be and motion.y is less than minus jump force divided by 2 in the if statement. And look at that, we have a variable jump now. So beautiful, I know. Anyway, let's actually just start setting up a function to apply our animations. So function apply animations, and then pass input vector to it, and then pass for now and call it back in our physics process. And now I'm trying to get some better sprites, but apparently my internet wasn't working, so yeah. Anyway, our internet finally decided to work, so I went to opengameart.org and I found some sprites and some assets like music and stuff, and I saved it to the project folder of the project. And that's how you import stuff to Godot. And now make sure that you actually go to preset and set it to 2D, and then default that, and then re-import to actually properly import your stuff. You want to make sure that's actually done before you actually import it. And anyway, if you have a sprite sheet like this, make sure that you go into the animation tab and you set up the V frames and H frames and the actual frame that you want to use. Now V frames are pretty much like the rows, and then H frames are kind of like the columns. So it depends on the sprite sheet you're using. And apparently I forgot to actually add a collision shape for the area 2D, so make sure they actually do that. Anyway, back in our script, just do motion is equal to move inside, and this just makes the code better. Now to actually apply our animations, we want to do if input vector.x is not equal to 0, meaning we're moving, then on ready var, sprite is equal to $sprite, and that's basically getting our sprite node. So sprite.scale.x is equal to sign input vector.x. And if you want to know what sign does, control click on it and it tells you what it does. So yeah. Now if you're getting a weird issue with your jump, then just comment out this line of code in the apply gravity function we made. Now to actually make an animation, select your animation player, click on animation and then new, and then name the animation to whatever you want. And then in this drop down you can select whatever animation you want to work on. So over here is your animation duration, and then this is the snap value of your timeline. And then I'm gonna be working on the idle animation, so I'm just gonna animate the Y scale of the entire player. So to actually key that new value, we press the little key icon there, and that keys our value. And then I'm also gonna key the frame of our sprite and set it to loop. And yeah, look at that, we have up and down animation. Now for the rest of your animations, it's pretty much the same, except you're mainly just gonna key the frame value. And yeah, just do that. And for some of them you want to set it to loop, and for others you don't. Now back in our script, do onReady var sprite animator is equal to animation player. And this is pretty much gonna get our animation player node. So then sprite animator.play, and then the name of your animation that you want to play. So then in the else, which means that we're not moving, sprite animator.play idle. And look at that. If we play, we have some animation for our player now, and it's not as boring anymore. So look at that, we're making progress. So we're almost there, so we're just gonna do this for our jump now. So if not is on floor, sprite animator.play jump, and then and it's on floor for the friction as well. So I made a new scene with a tile map, and I just renamed this to level. And now we're gonna set up a tile map to actually have make our world. So just click on the tile map and then add the sprite or tile sheet that you want to use for your tile map, and then new single tile, and then I'm just zooming in, and then specified a region, and then set the step to whatever size your sprite is, so 16 by 16 in this case, and then go to collision, and then just add a square collision to it basically. And then in the cell size, make sure that it's the same as your sprite size, and look at that, we actually can make a level now. Now to make a new auto tile, you click on new auto tile, and then you select your region, go to bit mask, and then make sure that the subtitle tile size is set to 16, and you set to a minimal bit mask size of 3x3, and then just color stuff in, and then set a collision. In this case I'm using the polygon collision shape option instead of the rectangle collision shape, so just add the points and stuff to your tile. So yeah, just go ahead and do that. And once you're done, look at that, we have an auto tile set. Beautiful. Anyway, I instanced the tile map into our world, and if we play, look at that, our actual level is actually in our world now, and we can just jump on the platforms and stuff, I guess. So to make our level exit, I made a new scene and added an area 2D, and I just called it exit. You can name it whatever you want, and then I'm using the color rect for it. So you can add a texture rect, or you can add a sprite to it. I'm just using the color rect like I said, and then the label, calling it exit. And now in the layout, make sure that it's set to full rect, and then I just centered it. And then you gotta, obviously give a collision shape to your area 2D, so go ahead and do that as well. And there we go, that's pretty much it. Now with our area selected, add a script, and then in Node, give it an area entered, signal and connect it to itself. And then I just, rename that to player. You don't have to, I just did, just because. Anyway, git 3 that change scene, and then to level. And then I'm just gonna actually set up that variable, so export string, file. And then the var, and then the name of our variable, which we called it level, and then we assign it to a default value by clicking and dragging the world scene as the default value. And yeah, that's pretty much it. So now we gotta actually make sure that the collisions are properly set for the area 2D. So in the settings, go down to 2D physics, and then set up your different layers. So layer 1 is going to be our player, layer 2 is going to be the world, and layer 3 is going to be our exit. And then you can basically, for the exit, you can have it not be in any layer, and just make sure that the mask is set to look for the player. So yeah, just set the mask to player, and yeah, there you go basically. Now back, and we want to actually instance a new scene with our from our world, and we can just rename it to pretty much whatever we want. I'm just calling it level 01. And then on our tile map, I can just erase stuff and modify it and change it. And look at that, we are basically making a new level. And then just save it, and now I'm just changing the default level to be the level 1. And yeah, I did another instance of the world, and apparently we have an error here, so get that, remove that comma, and you should be good to go. And back in our player scene, make sure that it's actually set to the player layer, and then the mask is set to world and exit. And apparently, before we continue, I apparently forgot to add a remote transform 2D node, so make sure you add that to the player because it's kind of important. Now back in our main scene, world scene, we want to add a camera 2D, and then we can enable smoothing if we want, but we definitely need to make sure that current is set. Now right click on the player, set edible children, and then in the remote path, assign it to the camera that we just added. And then we want to instance our exit in our main world, so that the inherited instances actually get the exit as well, and then we can just move the exit to wherever we want it in our levels. And yeah, pretty much that's it. So with our exit selected, there's a level field thanks to the export variable that we set up, and then we can just set whatever level we want the exit to lead to. And then apparently I forgot to add a collision shape for my player's area 2D, so make sure that you also kind of do that, because otherwise the exit won't work. So yeah, make sure that it's properly set with its layers and masks as well. And now if we run our game, and if we make it to the end into our exit, it takes us to the next level. And look at that. Now we're just gonna add a double jump just for fun. So this is pretty simple. So just var num jump is equal to 2, and then in our jump function, in the isOnFloor function, we want to reset the num jumps back to 2. And then if num jumps is greater than 0, then we can actually jump. And then we gotta make sure that we actually decrease our jumps inside the is action press if statement. So num jumps minus equals 1. And with that, we actually have a double jump now. Look at that, we're almost there. We basically have the entire player movements and everything set up. And I'm just adding a script to our world. I'm calling it game state. You can name it whatever you want. And we're gonna, start setting up our respawn. So on ready var player, and then equals to $player to get our player node, and then on ready var respawn point, which we actually haven't set up yet. So we're gonna add a position 2D node to our main world, and just call it respawn point or whatever you want, and click and drag it to whatever position you want. And then back in our script, we want to get that node, so do $respawn point. So on function ready, we want to set the player's position to the respawn point position. So function process delta and pass for now, and then function die, and if player dot position dot y is greater than 300, then the player position is equal to respawn point dot position. And apparently I didn't actually use the variable we set up, but yeah. And then make sure that you actually call die in the physics process. And now if we die, well, fall off the stage, we get respawned. And yeah, with that, it's pretty much done. There's just a few remaining bits left, but I separated that in the second video to, not bore you guys out of your minds. If it's so, it will be somewhere here on screen somewhere. So anyway, thank you guys so much for watching, and make sure you subscribe for more. And if you have any questions, feel free to leave them in the comments. Anyway, see you guys later.